Thank you, Seth. We're talking about problem solving with quadratics. Alright, and I'm not going to lie, this will be challenging. Particularly the part where we have to develop the equation, okay? That's going to be the hardest part about this. Other than that, Noah, we're just solving quadratic equations, okay? And we're going to perhaps rely on our calculator a little bit to assist us with some of these ones, rather than factorising or using quadratic formula, because we're not so interested in solving quadratics here. We've demonstrated that already. We've developed that skill. All we're looking at now is how we can apply real world applications of quadratics. So here we have a little bit of a riddle. Two integers differ by 7 and the sum of their squares is 25. So in the notes there I've written up the process. Alright, process 1, develop the relevant equation. And I've just said this is going to be the hardest part. Alright, because you're looking at that and you're going, what? How on earth am I going to make an equation out of that? Okay? Once we've got the equation, we're going to solve it and then reject any illegitimate solutions. So, two integers. We don't know what these numbers are. An integer just means a whole number. It has to be a whole number. So I'm going to let the first one be x. Alright, that's always the case. Like x is very big. And the second one then, it's different from it by 7. So we can take two parts here. We could call it x plus 7 or x take 7. It's not going to make a difference to our answer. Alright? But we have the first number, and then the second number is different from it by 7. Either 7 more or 7 less. Doesn't matter. Alright? So there are two numbers. Now we're told the sum of their squares is 25. So that means x squared plus x plus 7 squared is equal to 25. And we have an equation. Okay, so that's the trickiest part, isn't it? We've just got to form an equation from this piece of information. We're going to expand it, move everything to the left-hand side, and see if we can factorise it, and if we can't, we'll just use our calculator. So here I'm going to apply the perfect square expansion rule. Move everything to the left-hand side. We're going to have 2x squared plus 14x. We're going to have 49 take away 25. What's that going to be? 24. We can divide the whole thing by 2. All right, or pull half out the front or something like that. So I'm going to multiply both sides by half or divide both sides by 2. We can do that because on the right-hand side we've got 0, so it's not changing the value of the right-hand side. And now it's a lot easier to factorise. You can factorise it in this step. Alright, you can do it, but the solution becomes heaps more clear when we don't have a number here, when we have what's called a monic quadratic trinomial. So if we're going to factorise this, multiples of x squared to x and x, multiples of 12 that add to 7, 3 and 4. So we can see 3x plus 4x will give us 7x. So this is our solution, x plus 4 times x plus 3 is 0. Okay, so we've found the two possible values of the integer, but we need to find the possible solutions to the problem. So, remember, these were our numbers we started with. We said the numbers are x and x plus 7. Okay? They're the two numbers we started with. So if our solution is x is minus 4, right? If x is minus 4, then the other solution is going to be positive 3. So if x is minus 4, then the other integer is going to be minus 4 plus 7. Minus 4 plus 7, which is 3. And then in the circumstance where x is minus 3, if x is minus 3, then the other integer is going to be minus 3. Minus 3 plus 7, positive 4. So we've got 4 sets of numbers that satisfy this. Okay? So we generated 2 solutions here. And then we had to apply those solutions. We say, okay, when x is minus 4, what's the other integer we're talking about? Because minus 4 and minus 3 don't satisfy this. Minus 4 and minus 3, what's the difference between them? 1. Okay, Okay, so they don't satisfy the description we had at the start. All right, so that's an example of a number one, and I'm going to be floating around and I will help you develop some of these equations and maybe we'll do a few of them together. But that's a good example of like maybe the first two problems or a bit like that. And then we get into some involving shapes. So here I have a rectangular paddock, has a perimeter 1,000 metres and area 6,000 metres squared. Okay, so when you get a question like this in the test, it's going to be broken up into a number of parts. Okay, the first part's going to say something like, show that the equation for the area is this. So we're going to develop an equation for the area. We're going to make the equation for the area equal to 6,000, and then we're going to solve it. So sort of three parts to it. So what we have to do here is let's sketch a diagram of it. All right, it's rectangular. We're not sure of its dimensions, but that's what we're trying to find. And I'm going to call this side x, which means this side also has to be x. And the perimeter is 1,000 metres. So that means I need to come up with an expression for these sides that's going to make the total distance around the outside of the shape equal to 1,000. All right, so there's not really an easy way to explain this. I'm going to show you, and you'll be like, oh, of course. Remember, we want the total distance around the outside to add to 1,000. Well, if I put 500 take x here, and 500 take x here. All right, we've got x plus 500 take x, so that side's going to add to 500, and then x plus 500 take x, that's 500 there, plus 500 here, you've got 1,000. Okay, so how did I do that? I said, well, one side's going to be x, and the other side has to be half of the total perimeter, take away x. All right? And then if we're thinking of, okay, so that's the dimensions in terms of x. So then what is the area of this shape? Well, the area is going to be length times width, isn't it? X times 500 take x. And this is equal to, x times 500 take x is equal to 60,000. All right, we're going to expand it, move everything to the left side, and we've got a quadratic. Take 60,000. That there. So we've come up with an expression for the area, an equation for the area. We need to solve it. Now looking here, it's like, who knows the multiples of 60,000? You know, it can be a little bit difficult to anticipate when we're dealing with really big numbers, and so that's when we're going to use our calculator. So I'm going to list some instructions up here on how we're going to come up with our calculator. Notice how I've arranged this quadratic in terms of general form. So you can clearly see A, B, and C. Our value of A is -1, B is 500, and C is minus 60,000. So here's what we're going to do. We're going to menu, equation solver, polynomial, and we're talking about a quadratic which has two unknowns, or it has a degree of 2. So we're going to press 2, and then you're just putting in these values, just the numbers, -1, 500, and minus 60,000. On your calculator, I think it looks something like this. -1, 500, and 60,000. Minus 60,000. All right, so let's do that now. Let's find our solution. Okay, and so it'll pop up. There's a square box there, and you can just see both solutions. X is 300 or X is 200. So this is a procedure you can use to solve any quadratic. Okay, you can use it to assist you when you're factorizing. So we've got the value of X is 300. All right, so let's look at this. X is 300 or X is 200. I'm just going to rub out these instructions here. In the circumstance where X is 300, we're going to have a shape that is 300 that way, so that's 300. And this length here is going to be 500, take 300. This length is going to be 200. All right. In the circumstance where X is 200, we're going to have this length is 500, take 200. This length is 300. And these are exactly the same shape. Okay, they just have a different orientation. They both have the same dimensions. And so the dimensions, we're asked to state the dimensions. We have to answer the question. Therefore, the dimensions are 200 meters by 300 meters. All right. Spin this board around. Okay, any questions about that one? Okay, so look, I mean this here, like solving the equation, not so hard. Here we had to state the solution, not so hard. This is quite challenging. Okay, so this is a skill we're trying to develop, because this is a skill we're going to need a fair bit in Year 12, is being able to develop the equation. However, let me state this very clearly. In the test, all right, you're always going to have part A, it's going to say, show that the area is this equation. All right, so what that means, it's going to give you everything you might need to solve later on, so that if you can't get part A, you're not penalised for it in any way. And so it'll say, show that the area is this, and so that'll mean you need to draw a picture and state, well, the area of this rectangle is length times width. That's what we've done there, and the area is equal to 60,000, and then we bring it all together. Okay, let's look at the third one. We've got a rectangular based box, has a height of 5 centimetres and a volume of 280 centimetres cubed. And one side of the base is longer than the other side, 1 centimetre longer than the other side. So, here's the rectangular base, all right, and it's 5 centimetres high. So this is 5. Let's draw it. It's 5 centimetres high. And one side, let's call this side X, okay? So if this side is X, then this side is 1 centimetre longer. So this is going to be X plus 1, all right? It's X plus another centimetre. Now the volume of a rectangular prism is length times width times depth. All right, which is going to be 5 times X plus 1. And the volume is equal to 280 centimetres cubed. So we've developed an equation, and now we're going to solve it. Here we'll have 5x squared plus 5x take 280 equals 0. And we'll use that calculator. So for this exercise, I'm going to encourage you to use technology. Now the solutions we get, now we could divide by 5 here, and you might be able to see a simple solution for factorising. In fact, now that I've done this, it is. We've got x is 7 or x is minus 8. Okay, one more step. It says find the dimensions of the box. Okay, so look, we've found the value for x. We've found 2 values for x. One of them's not right. Why is one of them wrong?
We can't have a negative.
Yeah, we can't have a negative length. Okay, so our third step says to reject any illegitimate solutions. So we're going to reject this one. We're going to reject it. And so that means this is the only solution we're interested in. And we need to state the dimensions of the box. Okay, so the dimensions are going to be 5 by 7 by 8. That's our solution. So, 2G, let's give it a go. Please ask questions. Please let me help you out. I might put some sort of direction up here to maybe help us out a bit as well. Excellent. Let's get into it.